Hello everybody and welcome to this multiplying polynomials video. I'm going to put two videos together. This one's going to be more basic and the second one will go over some higher level things. Okay, the first type of polynomial multiplication we're going to look at is monomial times a monomial. So we'll look at our first example. 2x times 3y. You likely remember this type, but I want to start basic and we're going to build up from here. So the first thing we're going to look at is, or talk about, is we multiply the coefficients together. So 2 times 3 equals 6. Then we start looking for like powers or like bases. You can see that there's only one x out there, so the x stays the same, just x. And then y is unique as well. So we get 6xy. If there were other x's, we could combine them to make a larger x, like maybe an x squared, x third. Same with the y's, but there weren't. So when they're unlike powers, we just write the letters down. Let's look at another one. b. 4a to the power of 3, negative 5a squared. Once again, coefficients go together. So 4 times negative 5, negative 20. Now these a's, we want to check these a's out. I guess I could use a different color, couldn't I? Let's use the blue. Remember that when you're multiplying like powers, you actually add the exponents. So it's going to be a to the power of 3 plus 2. So negative 20 to the power of, or sorry, negative 20, a to the power of 5. I think I can squeeze one more in on this slide. Let's say c down here. Negative 2a squared bc. 3a b squared c to the power of 3. Negative a times b. Sorry if that's taking a little while for me to write that down. All right, so again, we want to look at the coefficients. So negative 2. 3, and there's actually a 1 here, so it'd be negative 1. So I multiply those three together, and I might as well keep my red going. Negative 2 times 3 is negative 6, times negative 1 is positive 6. Now we'll look at the a's. So a squared, a, and there's an a there as well. Reminder that everything has a power of 1. So it's going to be a squared times a to the first times a to the first. So 2 plus 1 plus 1. Let's go with green for the b's. So here's a b, b squared, b again. Everything has a power of 1. So it's b to the first power and b to the first power. Everything has a power of 1 unless shown otherwise, because you can see that 1 has b squared. So b, 1 plus 2 plus 1. And then finally the c's. And I'm sorry if this is getting kind of crowded. There's only two types of c's. And again, this is c to the first power times c to the third power, so 1 plus 3. And now I can just simplify everything. So 6, a to the power of 4, b to the power of 4, c to the power of 4. Let's look at one more example. We're going to bring some fractions into it. I could hear people freaking out through the video. I'm just going to be quiet here as I write this out. No need to talk. All right, same idea. When there's fractions in the mix, though, it might be nice to group them. So what do I mean by that? Another thing we can do is we can group things before we multiply. So what I mean is I could actually put the coefficients together. Then I guess I could put the d's together. And then the e's together. And again, this is going to be e to the first power. So you can do that whenever. This is just a rearrangement. And then you just kind of look at everything one at a time. Fractions. I always stress to reduce my fractions before I multiply. So if you don't know how to do that, I'm not going to be able to go into it in detail in this video. It would take too long. Come find me, or maybe I'll make another video on just that later. But anyway, I'm going to look at for a common factor between any top number with any bottom number, so any numerator with any denominator. I see these 5s, so I can divide them both by 5. And let me get my color here. 5 divided by 5 is 1. 25 divided by 5 is 5. Then I see that there's a common factor of 3 between these two. Divide them both by 3. I'd get that. Now I can rewrite my fraction. It's going to be really 1 times 2, or negative 2, so negative 2 over 5. Now I can multiply straight across. So I went 1 times 2, and then 1 times 5. And then for the rest of it, I can just clean that up real quick. 3 plus 4 is 7, and then with the e's, 2 plus 1 is 3. So that's a grouping method. For more complicated things, sometimes you like that, or people like that. It's not necessary, however. And here you can see where the steps that we used. To multiply monomials, you multiply the coefficients, then you multiply the powers, the like powers. And when you multiply like powers, you really just add the exponents. All right, section 2, monomials times binomials or larger. So I'll write down our first example. Okay, so everything is built off monomial multiplication. If you know how to multiply a monomial times a monomial, everything else should be easy. So in other words, if you could do the first section, this section should just be fine. For multiplying a monomial times a binomial or larger, we distribute. What that means is we're going to take this one monomial and multiply it to many other terms. So in this case, just 2 terms. So this first multiplication, 4a cubed times 2a to the 5th. Well, 4 times 2 is 8. A to the 3rd times a to the 5th. Remember, I just add those exponents, so I get 8a to the power of 8. Once I'm done my first multiplication, I distribute the 4a to the 3rd power to the next term in line. So if there was 3 terms, I'd have 3 distributions. If there was 10 terms, I'd have 10 distributions. This question only has 2 terms, so there's 2 distributions. 4 times a positive 6 is a positive 24. A to the 3rd times a to the 4th, I add those exponents, I get a to the 7th. So again, pretty straight ahead, monomial multiplications all over the place. Let's look at another one. Negative 5, a squared, j to the power of 3. I think I said I'd be quiet when I write these out, didn't I? So maybe I should listen to myself. All right, sorry for that little bit of wasted time there. And then we'll get right into it. So now I distribute this entire term to here. Take your time, just treat it as a monomial multiplication. Negative 5 times negative 3, that's 15. A squared times a to the 3rd power, I add my exponents. A to the 5th. And the j's, 3 plus 2, they'll be 5 as well. I'm done that. One more distribution. Negative 5 times positive 4 is negative 20. A squared, this times a, but remember that's a to the 1st power, so that's going to be a to the 3rd power. J to the 3rd power times j, which is really j to the 1st power, so j to the 4th power. And we have a 3rd term, so this is a monomial times a trinomial. So we just have a 3rd distribution, not a big deal. One more monomial multiplication. Negative 5 times negative 7 is positive 35. And then you can see the negative 7 has no other powers or letters or variables with it. So the a squared j to the 3rd power remains unchanged. And there we go. That's our second example. Once again, I'll post some steps here. To multiply a monomial by a binomial or larger, distribute the monomial to each term in the polynomial. Perform each individual monomial multiplication. Okay, our last section for video 1. Binomials times binomials. So I'm going to go 5x minus 3, 4x minus 7. Once again, we simply have to perform monomial multiplications, and it's going to be distributions that kind of give us that. So we take this first term, and I distribute it through the second term. So it's going to be 5x times 4x, and then 5x times negative 7. So I'll keep the color going here. 5x times 4x is 20x squared. And then 5x times negative 7 is negative 35x. So we've performed our first distribution. Now we take the negative 3 and we distribute it all the way through. So negative 3 times 4x is negative 12x. And then negative 3 times negative 7, positive 21. Now you'll notice here, what color should I use? I'll use black. That we have some like terms right here. What do I mean by like terms? Terms with the same variables with the same exponents. So it's x to the first power in both cases. When you have like terms, you combine them. So you pay attention to whatever the signs say and you put them together. So 20x squared stays the same. Negative 35x, subtract 12. So it's like adding backwards. Minus 47x. And then plus 21. So again, if you can perform monomial multiplications, you can do any type of polynomial multiplication. Let's do another one. 2x minus 9, 4x plus 11. Okay, take your first term, and we're going to distribute it through that second polynomial. So 2x times 4x, 8x squared. 2x times positive 11. Well, really just go 2 times 11, which is positive 22, and then x has nothing to be multiplied with, so it remains as a simple x. Now we take our second term, distribute it through. That's a negative 9 times 4x, so negative 9 times 4 is negative 36. And again, there's an x there, but it has nothing to be multiplied with, so it remains unchanged. And then negative 9 times positive 11, negative 99. Once again, whenever you do this sort of multiplication, where you have the same variable involved, you're going to have these middle terms, or often we'll have these middle terms, maybe I'll just say, collect them. Middle-like terms, to be more accurate. Again, because they're both x's to the first power. 22 minus 36, if you think about that, that's negative 14x. So when we're combining like terms, we never change the variable or the exponent. So we're just saying that there were 22 x's and we took away 36 x's, so now we're 14 x's in the whole. We don't turn them into x squareds or anything like that. And then minus 99. I think once again we could squeeze this in. You know what? Why squeeze things in if we don't have to? Let's go to one more slide. All right, final example. And again, you might not even need this. If you get the pattern and you understand how to multiply monomials, then you're going to find all this easy. This is more or less a review of the video 1. Video 2 will get into some more challenging things. Okay. First term, distribute it. So 3x times 2x, 3 times 2 is 6. X times x ends up being x squared because they're both to the first power. Then 3x times a positive 1 will be a positive 3x. Once we're done the first term, move the second term in the front polynomial, distribute it through. 7 times 2x is positive 14x. 7 times a positive 1 is positive 7. Once again, we have these like terms in the middle. I'm saying I have 3 x's, and then I found another 14 x's. So in all, I have 17 x's. I do not change these middle we don't change the x's into x squareds or anything when we're adding. We're just talking about how many x's we have. There we go. Again, summary. So to multiply a binomial times a binomial, distribute each term of the first binomial through the second binomial. That's it for video 1. Hopefully that made sense. If it didn't, watch it again or come find me, email me, however you want to contact me. Have a great night, everyone.